Alright, so this is a quick little video that I've made to show you my hard button project, and a few of my coworkers and myself thought it would be funny to take the Staples easy button and convert it to its antithesis, the hard button. And just like you might expect, this is what it does.
That was hard.
So we're hoping to make some good quality use of this in meetings at work. Physically, I tried to preserve as much of the original easy button as I could. So the top is the original button, but I carved away parts of the letters and added some epoxy putty to make up for portions of the letter that I couldn't carve out of the original to form the new letters, and I was able to keep the A completely original. And then after the epoxy putty set, I used a Dremel tool to carve that into the shapes of the letters, and this is the result. I had to repaint this as well to make it look presentable, especially to get the white on the top surface. So what I did there was to mask off the tops of the letters with masking tape, spray paint several coats of red, remove the masking tape, use clay to mask off the openings in the letters and the space between them, and then spray paint several coats of white over the letters. And that was probably the most difficult part, actually, of this. So I preserved the original power supply, these two AAA batteries, and inside, if we open it up here, show you what's going on the inside here. This is actually quite a nicely designed item for a mass-produced consumer product. And almost got it here. Oop, there we go. So this is what the inside looks like with my modifications. Let me see if I can zoom in on this a bit here. Kind of awkward with my camera, excuse me. So on this circuit board, what I have is really just this chip, which is an ISD1740, or it might be 1740. I know offhand I'm not sure about the part number. But this is a chip that was made by a company called Information Storage Devices, which then became was bought by Winbond, and I'm not even sure what the ultimate fate of it was. But this is a pretty cool chip that stores, it's a sound recorder and playback device, single chip solution, and it actually stores the sound as analog values in an E2PROM array. And it also contains, the state machine and everything needed to do the automated playback. And so I just, recorded myself saying that was hard. And once I was happy with the recording on my computer, I transferred it to this chip by just feeding it into the analog input pin on the chip, which is meant to accept higher levels than a mic level input, and recorded it on there. And now it's just set up to play back whenever you push the play button there.
That was hard.
Occasionally there's a little false stop there. I don't know exactly what happened, but there's just a few support components, mainly bypass capacitors on here. The button in the middle, I was able to preserve or reuse this elastomeric piece and this retainer clip by making the appropriate footprint on the circuit board. But the original, let me get the original circuit board. The original circuit board is here, and as you can see, the original circuit board used a gold-plated fingered keypad button layout on the circuit board, and there's a carbon button inside the elastomeric part that you can see in the middle, that dark circle, and that's what the original key switch was. There was no actual soldered switch component. I couldn't really redo that without having a gold-plated circuit board, and that's a considerably higher expense in low quantities, so I actually used a standard little surface mount push-button momentary switch underneath of this thing, and by lifting it a little bit higher off the board and soldering it onto the board instead of just bending the tabs, I got that to work pretty well with the switch. You can see the original design is preserved here for the spring. The spring is actually what the four prongs or fingers on the bottom of the button actually engage with, and then the middle portion of the button, as it comes down, contacts the actual switch. There's an 8-ohm speaker under here. There's a couple of weights which seem to be steel. They're definitely ferrous metal to help hold this down, and then there's the battery pack over on this side. So pretty simple little project, and definitely got a kick out of doing it, and my coworkers did too. So thank you for watching.